2 years ago, I lost my only brother, Kurt, to a rare pediatric brain tumor. In fact, I lost him twice. I remember that day when he was diagnosed more than 30 years ago. Kurt and I were on the varsity soccer team together. We were growing up in the Midwest, and it was an August day, hot, hazy day in the Midwest. And Kurt was developing symptoms of migraine headaches, vision disturbances, nausea, and vomiting. And we thought it was just the hot, hazy days of summer growing up in the Midwest. We didn't know that underneath him there was a fast-progressing tumor in his brain. And very quickly, within about a week of his symptoms, he collapsed one day at practice. He was rushed to an emergency room. And he was immediately transferred the next day to a cancer center nearby and had neurosurgery. And in fact, I didn't even get a chance to really hold his hand or say goodbye or talk to him before he went in. When he recovered after several weeks in the ICU, his battle with cancer wasn't over. He received multiple months of chemotherapy and radiation, whole brain radiation. This was the best science had to offer at the time. But this is the first time I lost my brother. Because he was cognitively and physically disabled for the rest of his life. And he needed to be cared for by my parents for nearly 30 years. So this motivated me, this experience, to go on and become a cancer biologist. And I've worked in some of the leading biotechnology companies. For example, at Amgen, I worked in the research lab along some of the world's best immunologists and cell biologists, discovering and researching new ways. I wanted to be a part of finding a new way to help people like Kurt, because I felt so helpless. I felt so helpless that I couldn't do more for him. Eventually, the side effects of the treatments he was on began to show up, and Kurt suffered from progressive neurodegenerative diseases from the radiation and so forth. He developed Parkinson's disease, and he passed 2 years ago in June of 2019. And that's when I decided to recommit the remaining years of my professional working career to help companies transform the way we treat cancer patients. We must do better than chemotherapy and radiation. And I'm working now with companies that are on the leading edge of developing new cell and gene therapies using our own immune cells to help treat cancer. But cancer is personal, right? You all know someone like my brother Kurt. What are the thoughts or emotions that come to mind when you hear the word cancer? Is it sadness? Being afraid? Maybe sadness at the thought of losing a loved one? Or maybe it's fear of knowing that you're potentially having to go through these multiple months battling your cancer with chemotherapy, radiation, and so on. What if it didn't have to be that way? Well, there may be a better way. What if we were all living drugs? Recent breakthroughs in our understanding of the immune system has enabled us to develop one-time treatments using our own immune cells to fight cancer. And in fact, there are several recently approved FDA products that use these weaponized T cells from people's own bodies to treat some forms of blood cancer, like some types of leukemia and lymphoma. And it had remarkable results, amazing response rates and long, durable remissions. So I'd like to invite you all to think of yourselves as beautiful bioreactors. You know, a bioreactor is a closed system we would use when I was back in the lab at Amgen. We would use these bioreactors as a closed system to grow human cells. But within each one of you is the near perfect conditions of temperature and abundant nutrients to grow your own immune cells. And there's a special type of immune cell called a T cell. The T cell is coated with proteins called T cell receptors. And these beautiful cells are going through our body throughout every day, looking for abnormal, foreign invaders like viruses and bacteria. What you may not know is they're also performing immunosurveillance, looking for abnormal cell growth. In fact, tumor cells have a unique fingerprint, a molecular fingerprint. There are abnormal proteins on the surface that are unique to every person. And those T cells can recognize them normally and kill them. But there's a paradox at the heart of cancer discovery and research. Because when I was in the lab, we would use powerful microscopes and stains, these fluorescent stains, and we could visualize the tumor tissue. And inside that tissue were legions of T cells surrounding the abnormal cells. Why is that? Well, the cancer and tumor cells has evolved to find ways to suppress those T cells, to make them dysfunctional. And for years, this remained a mystery. In fact, this phenomenon has been known for more than 50 years. There was a husband and wife team of scientists in Europe more than 50 years ago that named this phenomenon the Hellstrom paradox. So yes, this remained a mystery until just very recently. There have been 2 scientific breakthroughs in the last few years that have accelerated our ability to use our own immune cells to treat various types of cancer. The first came from studying bacterial cells and how they defend themselves from virus infections. And they have a very elegant way. They have these enzymes that just chop up the virus into pieces. Those enzymes, those molecular scissors, that discovery was then used to develop CRISPR gene editing. Imagine with CRISPR gene editing, we could replace a defective part of the genome, a mutation, let's say, or we could weaponize a T cell with this technology to make it much more infectious and able to target cancer cells. To use an analogy, it's like imagine 1,000 miles of railroad track and wanting to go in with CRISPR gene editing and just take out a 1/4 mile of track and replace it with good, normal, healthy track. This technology is being used around the world to find ways, and using different immune cells to find ways to weaponize T cells to fight and treat cancer. And not only cancer, but other diseases, like sickle cell disease. So I believe in a world in the future where we will be able to harness our own immune systems, our own beautiful bioreactors within us, within each of us, to fight cancer. And my wish for you when you leave today, my hope is that when you hear the word cancer, you have feelings of hope and empowerment of being able to take back your own healing journeys. It's too late for my brother Kurt, but it may not be for someone you love.